Hello students, as in the last lecture we saw the type number 3, that means the third exercise of linear regression, in which we saw how to find the mean value of x and y, that means x mean and y mean, how to find the correlation coefficient between x and y. The meaning of correlation coefficient means small r, remember this, and how to find the standard deviation of y or x when we have variance. As in the last lecture we saw how to find the mean of x and y. Simply what you have to do, you have to solve these two equations simultaneously to get the answer of x and y. Indirectly, that x and y is what? It is x mean and y mean. To find the correlation coefficient, we have to consider the first equation. As we saw in the previous lecture, the concept that the first equation we have to consider y on x and the second equation we have to consider as x on y. So when you will consider the first equation as y on x, you will get byx. When you will consider the second equation as x on y, you will get bxy. After getting byx and bxy, simply you have to see the product of this two value. It should be less than 1. If it is less than 1, that means our assumption of considering equation number 1 as y on x and second equation as x on y, it is perfect. After that only we can find the value of r, that is plus minus square root byx into bxy. Okay, and we know that the answer of r, either it will be plus or it will be minus. It cannot be both. If byx and bxy both are positive, then r is positive. If byx and bxy are negative, then r is negative. As I told in the previous lecture, the value of r, it will lies always and always, it will lies between minus 1 and 1. In simple language, the value of r, when you will see the backside answer of each and every sum of third exercise, or whenever you have to find the value of r, it will be plus 0 point so and so number or minus 0 point so and so number. So that's why I told the value of r, it should lies between minus 1 and 1. Okay, now in this lecture we'll gonna see the case 2. We'll consider this as case 1 and this as case 2. Now what is a case 2? If in case our assumption is wrong of considering the first equation as y on x and second equation as x on y. So if the product of these two is greater than 1. So in the second case, what we will do, we'll consider the first equation as x on y and second equation as y on x, in which when you will consider first equation in the second case as x on y, you will get bxy, and in the second equation you will get y on x. Again you will check, as we did in the case 1, the product, it should be less than 1. Here also in the case number 2, you will check the product of these two, it should be less than 1. If it is less than 1, that means our assumption is right. After that only we can find the value of r. Okay, so r is what? Plus minus square root byx into bxy. As we know that the regression equation y on x is what? Y equal to byx x plus a, and this is what? X on y. Remember, as I told in the previous lecture, the coefficient of y and the coefficient of x, it should be 1. Okay, and you have to apply this two formula whenever you have the standard deviation of y or standard deviation of x, and you have to find byx or bxy. In such case, you will apply this formula. As I had explained in the previous lecture about the variance and the standard deviation also, whenever you have the variance and you have to find the standard deviation, simply you have to find the square root of that particular number to get the standard deviation. That's it. Understood? As I hope you all understood the case 1. Okay, so now we'll move on to the second example, where we'll see if what? The value is greater than 1. So let's take the second example. So now we'll see the second example. Here it is given that two lines of the regression are 10x plus 3y minus 62 equal to 0 and 6x plus 5y minus 50 equal to 0. And then you have to find the value of r, then x mean, y mean, and then you have to identify the regression x on y and y on x. Okay, now so here also we'll start with the solution. Will start with let, because we don't know about the first and the second equation condition, whether the first equation is y on x or x on y. So we'll consider the first equation as y on x and second equation on as x on y. After that, where you will get byx and bxy, we'll check the product whether it is less than equals less than 1 or it is greater than 1. If it is less than 1, so directly we can find the value of r. If it is greater than 1, that means our assumption is wrong. Then we'll move on to the case 2. So let ten x plus 3y minus 62 equal to 0 be the regression equation of y on x. So as we will consider in each and every sum the first equation as y on x. So what do you mean by y on x? We'll keep y on the left hand side and the remaining number and alphabet, that means x, on the right hand side. So this will go that side. So this will be what? Minus 10x plus 62. Okay, as we know that we have to make the coefficient of y and x as 1 whenever you will convert a regression equation y on x on y. Okay, remember this, you have to make the coefficient as 1. So here if you want to make the coefficient of y as 1, so we'll divide throughout by 3. So 3y upon 3 minus 10x upon 3, 62 upon 3. So the next step will be what? This will be what? 3 will get cancelled. So here we'll get y equals to minus 10 upon 3x plus 62 upon 3. Yes sir. So now we'll compare this equation, comparing it with y on x. So your y on x is what? Y equals to byx plus a. So where we can see that the coefficient of x is byx. So comparing the equation with y on x, y equal to byx x plus a, clearly we can see that the coefficient of x is what? Minus 10 upon 3, and here the coefficient of x is known as what? Byx. So byx is equals to minus 10 by 3. So here we got the answer of byx. Okay, now we'll move on to the next part. Now the second equation is what? 6x plus 5y minus 50 equals to 0 be the regression equation of x on y. If we want to convert the second equation as x on y, we'll keep x on right hand side and y and number on the left hand side. So 5y minus 5y, and this will be plus 50. Again same, dividing throughout by what? 6. So therefore 6x upon 6 equals to minus 5y upon 6 plus 50 upon 6. 6 will get cancelled, so you will be left with what? X equals to minus 5 upon 6y plus 50 upon 6. If you want to cancel this part, you can cancel it. Okay, as here clearly we can see that 3 we cannot cancel this part. Even 10 upon 3 also, 5 upon 6 also we cannot cancel. 50 upon 6, if you want to reduce, you can reduce this number. Okay, as but we require the value of bxy. Okay, so no need of cancelling this. If you want to cancel and show that in the next step you are getting the answer, here we cannot cancel as 5 upon 6 will be same. Okay, 225 is a 2 3 is a, so this we can add as 25 by 3, as we are interested in finding the value of byx and bxy, not a and a dash. Okay, so remember this. Okay, so now we'll comparing it with x on y. So therefore x equals to, okay, bxy y plus a dash. So therefore bxy will be equals to what? Minus 5 by 6. Understood? Now we'll check that if the product of these two, if it is less than 1, that means our assumption is right, and easily we can find the value of r. So therefore byx into bxy, will check now. Byx is what? Minus 10 upon 3 into minus 5 by 6. So in the next step we will get what? Byx into bxy equals to, here we can cancel this number, 2 5s are 2, 3s are, further we cannot cancel, so this minus into minus will be what? Plus 5 5s are 25, and this 3 3s will be 9. Here we can clearly see that when you will divide this number at 25 upon 9, your numerator is greater than the denominator. That means the answer will be greater than 1. Yes or no? Understood? As 9 3s it is 27, 9 2s it is what? 18. So 2 point something answer we will get. So here clearly we can see that the answer is what? No need of showing this step, directly you can write that after this step. The product of this two number is what? Greater than 1. So therefore our assumption of regression equation is false. Now what if our assumption is wrong? Now we'll move on to the case number 2. So here we'll write this as case number 1, as we come to the conclusion that clearly we can see that the first equation is actually, it has to be x on y, and second equation it has to be y on x, because if we consider the first equation for this sum as y on x and second equation as x on y, clearly we can see that the product of these two is greater than 1. If it is greater than 1, our assumption is wrong. Now we'll move on to the next part. If what? The product of these two is greater than 1. If it is greater than 1, that means our assumption is wrong. Yes or no? It is false. So now we'll consider the first equation. So now we'll consider Here we'll write, we'll consider now the first equation. Consider 10x plus 3y minus 62 equal to 0 be the regression equation of x on y. So therefore we'll keep x on right hand side and the remaining number and alphabet on the left hand side. Yes or no? After dividing throughout by 10, so here we'll get what, 10x upon 10 equals to minus 3x upon 10y plus 62 upon 10. So therefore x will be equal to what, minus 3 upon 10 y plus 62 upon 10. Now we'll compare this equation, comparing it with what, comparing it with x on y. So here clearly we can see that what is x on y, x equals to bxy y plus a dash. So therefore bxy is equals to minus 3 upon 10. Okay, and the second equation, now the other equation, that is the second equation, is what, 6x plus 5y minus 50 equals to 0 be the regression equation of y on x. Okay, so we'll consider this as the case 2. There are 2-3 ways to find the answer for the case 2, but I will suggest to go with this method. Okay, this method is also applicable in the board exam. Okay, so now y on x means what, we'll keep y on left hand side and the remaining numbers and x on the right hand side. Here also same, dividing throughout by 5. So 5 y upon 5 equals to minus 6 upon 5, 50 upon 5. 5 get cancelled, so y equals to minus 6 upon 5 x plus, if you want to cancel this you can cancel, otherwise keep as it is. Okay, it is on you, as we are interested in finding the value of bxy and byx. So we'll compare this, comparing it with what, y on x. So what is y on x? Y equals to byx x plus a. So therefore byx is what, minus 6 upon 5. Okay, now you will check for what, the third condition, condition number 3, byx into bxy equals to, so byx is what, minus 6 upon 5 into bxy is minus 3 upon 10. Clearly we can see that the value of bxy and byx both are negative. If both are negative, that means the value of r will be always negative. If both are positive, then r will be positive. So here we can cancel this 6 and 10. 2 3s are 2 5s. So therefore byx into bxy equals to, minus into minus is what, plus, 3 3s it is 9 and 5 5s it is 25. So here clearly we can see that the product of these two, as the numerator is less than the denominator, so answer will be 0 point something, yes or no, when you will divide. No need of showing this step, you can directly write as the product of these two is what, less than 1. If it is less than 1, that means assumption, here will write assumption of a regression equation is true. So therefore the value of r will be what? Now we'll find by using this formula b xy into byx. So therefore r equals to plus minus bxy is what? Minus 3 upon 10 into minus 6 upon 5. So therefore r equals to plus minus square root, minus into minus is plus. Okay, so this we can cancel. 2 3s are 2 5s are, so 3 3s are it is 9 and 5 5s are it is 25. Okay, so r equals to plus minus square root of 9 is what? 3, and square root of 25 is what? 5. Yes or no? So therefore r equals to, either the answer will be plus or it will be minus, as we know that when bxy and byx both are negative, so the value of r will be what? Negative. So when you will divide this number, so you will get 0.6 as the answer. And here we got the answer between the range, as I told, it should lies between what? Minus 1 and 1. Either the answer it should be plus 0 point or minus 0 point. Okay, so in this way you will find your answer. And here you will write the reason that since byx and bxy both are negative, so r is negative. Understood? So in this way you will find your answer in case if you see that the product of these two is less than, if it is not less than 1. If it is greater than 1, that means our assumption is wrong. If our assumption is wrong, so we'll interchange the condition. We'll consider, in the second case, we'll consider the first equation as x on y to get bxy, and second equation as y on x to get byx. And the rest part it is same. We'll check the product. We'll write our assumption is true. Then we will find the value of r. Understood? So I will explain the sum again. First, always and always, as we don't know the particular question, that the first equation is what? X on y or y on x. So what we will do for each and every sum of the third exercise, we'll consider the first equation as y on x only, because directly seeing the equation we cannot say that it is y on x or it is on x on y. So we'll consider the first equation as y on x and second equation as x on y. Check the product. If it is greater than 1, our assumption is wrong. So we'll move on to this case 2. If in the case 1 only, if you are getting the answer perfect, less than 1, our assumption is perfect, our assumption is right, then you will move on to find the value of r. As we know that the formula is what? R equals to plus minus square root bxy byx. Substitute the value, you will get the answer. So in this way you will find your answer whenever you have to find the value of r when the assumption is wrong. I hope you all understood the first sum, even the second sum, in which we saw the case 1 and case 2. Now we'll see how to find x mean and y mean. So now for this sum we'll see how to find x mean and y mean. I hope you all might be knowing how to find the value of mean value of x and y. This is x mean and y mean. Simply what you will do, you will solve these two equations simultaneously to get the answer of x and y. Okay, straight away. Simply what you will do, you will solve these two equations simultaneously to get the answer of x and y. Okay, so now as here I had solved the sum. Okay, simply I will explain here the presentation part. The first equation you will consider as the equation number 1. So we'll rearrange the equation as left hand side x and y, right hand side number. The second equation, that is 6x plus y 5y, will shift minus 50 to the right hand side. So now, as we know that in the simultaneous equation, we have to make one alphabet as a common. So here I took y, I selected y, we'll make the coefficient of this y as same. So we'll multiply equation number 1 by 5 and equation number 2 by 3. So this will be 50x, 3 5 is 15, and 62, 5 is 310. Equation number 2, we have to multiply by 3. So this will be 6 3 is 18, 5 3 is 15, 53 is 150. Now, as per the rule, out of this 4, clearly we can see that equation number 3 and 4, as the coefficient of y is same. So here we have to solve the equation number 3 and 4 simultaneously to get the answer of x and y. So here, as the symbol of y is same, both are positive. Okay, so both are positive means what? We have to subtract these two equation. So when you will subtract, 15y will get cancelled. 15 minus 18 is 32. 310 minus 150 is 160. Okay, 32 will go down, cancel, so you will get x equals to 5. So this x equals to 5, you will substitute in the equation number 1, either in equation number 2, 3 and 4. Okay, it is on you. So here I took equation number 1, so I substitute the value of x 5, so where you will get the value of 5, and then after getting the value of x and y here, for each and every sum you will write this step. Since the point of intersection of two regression line is x mean y mean, so indirectly or directly the value which we got by solving simultaneously this x and y is the value of x mean and y mean. So in this way you will find the value of x mean, x mean and y mean. Okay, so done with the first, second also. Now we'll see the third one in this question. As when you will see the same question, it is there in the exercise, but it's a question number 10th, where you have to identify the regression of x and y, or sometimes they will say you have to find y on x also. So here I wrote you have to find the regression equation both x on y on x. As we solved this sum, where we clearly see that in the case 2 we got the conclusion, we come to the conclusion that in the second case, in the first case we saw the product was greater than 1, so we took the second case where we saw the product was less than 1. So if it less than 1, so that means our assumption of regression equation is true. So from this we can say that the first equation actually it is what? X on y, and the second equation is what? Y on x. So that you will write here the first equation, that is 10x plus 3y minus 62 equals to 0 is x on y, and the second equation is what? 6x plus 5y minus 50 equals to 0 is y on x. Simply you have to identify the regression x on y and y on x. That's it. Okay, so that was the third part. I hope you all understood how to find the answer of R when the case 1 fails, and then you have to solve the sum further, taking the first equation as x on y and y on x, because as I told, for each and every sum you will consider the first equation as x y on x and second equation of as x on y. As here in this sum, as we took y on x and x on y, clearly we saw that our assumption was wrong. Okay, so actually for this sum the first equation actually it is x on y and the second equation is y on x. Understood? I hope you all understood how to find the value of R, x mean, y mean, and how to identify the regression equation in case if they ask this question. Identify the regression. Okay, so now we'll take one more example based on this sum. Okay,